Section 3.6, lines in the coordinate plane. So what we're looking at is building off of section 5 with lines and slope and looking at some specific equations of lines. So what I want you to understand about these forms of lines is that what's in the name is what the information is that you need. So the point slope form of a line, here's the equation right here. Y minus y1 equals mx minus x1. Now point slope form. M is the slope, x1 and y1 is a point on the line. So a point and the slope. If you have a point on the line and the slope, it's easiest to use point slope form. The slope intercept form of a line is y equals mx plus b. Now, the m is the slope, b is the y-intercept. So the slope and the intercept. If you have the slope and a y-intercept, that's going to be the easiest form of the equation to use. We have vertical lines that are x equals a, just where it crosses the x-axis. Horizontal lines, y equals b. B is where it crosses the y-axis. Over here, looking at pairs of lines, we'll have parallel lines. Parallel lines have the same slope, but different y-intercepts, so they are vertically separated from each other. Intersecting lines have different slopes, and then coinciding lines, they are parallel, they have the same slope, but they also have the same y-intercept, so they map right on top of each other. So looking at the examples in this section, it's really kind of a bunch of different scenarios. They're giving you some information, and then you need to write your answer in a certain form. So they're giving you the slope. So m equals 6. They're giving you a point. So that's x1 and y1. And they want you to write it in point slope form. How lucky for you. They want point slope form. They gave you the slope. They gave you a point. So y minus y1 equals m, x minus x1. So let's go ahead and fill that all out. Y minus our y1 value, which is -4. M, our slope is 6. X minus x1, which is 3. Clean this up just a little bit. Y plus 4 equals 6. X minus 3. And you are done. Don't do anything more than you have to. Just answer the question that's being asked. Example 2, write the equation of a line that passes through -1, 0 and 1, 2 in slope-intercept form. So they gave you 2 points, x1 and y1, and then x2 and y2. And they want slope-intercept form. So y equals mx plus b. So we need the slope, we need the y-intercept. They have not given us any of that information right off the bat. We're going to have to find it, okay? So let's first start with slope. Slope is the change in y over the change in x, y2 minus y1, divided by x2 minus x1. So y2 minus y1, 2 minus 0, over x2 minus x1, 1 minus -1. That's going to give us 2 over 2, or 1. Now to find the y-intercept, there's a couple of different ways that you could do this, okay? You could plot these 2 points on a graph, and then kind of see where it crosses the y-axis, and you have your y-intercept. I'm going to show you another kind of algebra analytic way to go about that. So we want y equals mx plus b. Now we know m. X and y can be any ordered pair on the line. So it could be this, it could be this. So if we can plug in for m, we can plug in for x, we can plug in for y, all we have left to solve for is b. So let's use this point, 1, 2. So plug 2 in for y, we have a slope of 1, our x-coordinate is 1 plus b. So 1 times 1 is 1. Let's take that 1 away. B equals 2. So we have our m, we have our b. y equals x plus. Woo. There we go. All right, x plus 1. So for examples 3 and 4, go ahead and problem solve those, figure it out. Example 4, determine whether the following lines are parallel, intersect, or coincide. You want to go back to the top, look at those 3 cases and what you need to determine each case, and you can check your answers with my completed notes online.